Fourth step, that is calcination. Now there is a need to convert given ore into oxide ore. As we know that hematite is also oxide ore, but we can use calcination to remove the impurities, or we can say that to remove the water vapors or moisture or volatile impurities. So hematite is a oxide ore, so there is not need of air, so we use calcination. Calcination is a process in which we are heating ore in absence of air. Heating in absence of air or oxygen is done in this process, because hematite also contain oxygen, so there is not a need to use air. In this process, firstly we take concentrated ore, concentrated ore and we are heating this in absence of air, and this process is known as calcination. And the ore obtained after calcination is known as calcined ore. In this process, and this process is done in reverberating furnace. This process is done in reverberating furnace, and we can observe the photograph or diagram of this furnace. This is a photograph of reverberating. This is a photograph of reverberating furnace. In this apparatus there, and here we heat some combustible substance, and when this burn, the heat produced from there will come there and will come in contact of concentrated ore, and here the heat or unwanted gases will be expelled from there. And this is chimney where the unwanted impurities or unwanted gases substance will be expelled from there. So in this process we heat the ore particles by this flow of heat, and the result of this process are firstly moisture removal. In this process, if moisture are present in ore with ore particles, then this will be gone out. And second, removal of volatile impurities. Volatile impurities means the substance having very less boiling point. So when we heat these substance, they will come into vapors and expel from there. So we can say that in this process we remove the moisture and the volatile impurities from an ore. And third, in this step we obtain oxide ore. As we know, hematite is also an oxide ore, so we can say that we obtain after this oxide ore of iron, that is hematite, and the particles of hematite will be pure and all impurities will be gone out, but there is presence of some trace amount of impurities in hematite ore. Now for next step fifth, that is reduction of ore, and reduction is done by smelting process. So here we use smelting process for reduction. As we know, the reactivity of iron is moderate. Reactivity of iron is moderate, so there is a need of chemical method, and we use smelting from chemical method. If the reactivity of metal is very low, so we can use only heating, but the reactivity of iron is not very low, the reactivity of iron is moderate, so we should use chemical method, and here we use smelting chemical method. And in this process reduction is done by carbon. We can use a normal reaction Fe2O3, that is hematite, plus coke. Coke is a form of carbon, and we obtain Fe plus CO. And now we can balance the chemical equation by writing 3 here, 3 carbon and 3 oxygen, and we can write 3 here, 3 carbon and 3 oxygen. Here are 2 iron present, so we can write 2 here, and this is done in presence of heat. So we can say that by this process we can obtain metal. And here the oxidation number of iron is plus 3, and here oxidation number of iron is 0. So we can say that oxidation number become reduces. So this process is known as reduction of iron oxide into iron, and after this reduction we obtain metal. This metal is not totally pure, it is an impure form of metal. And after this we use refining process to purify this impure metal. But in this step we obtain impure metal by reduction of ferric oxide by in presence of carbon and heat, and we use coke, a form of carbon, for this process. Now we can discuss briefly the whole process that takes place in this reduction process, and this is done in blast furnace. Calcination or roasting is done in reverberative furnace, but reduction or smelting is done in blast furnace. Now we can observe the picture or diagram of blast furnace. This is a blast furnace. In this furnace we used hot air to heat the ore. Firstly we will discuss about the blast furnace. This is a blast furnace. It is a tall cylindrical furnace made of steel. At the base of the furnace, there is arrangement for the introduction of hot air. Here theories are present from which we introduce hot air in this apparatus. And here are two taps present there. First one is here. This is an outlet for slag, and second one is here, and this is outlet for molten metal. So we can say that there is a arrangement in lower part of blast furnace. Theories which are present to introduce the air, and two taps. Upper tap is used to remove slag from there, and the lower tap, this is used for removal of molten metal. And here now we can discuss about the reaction which is involved in this process. In this process we introduce ore, that is hematite Fe2O3, and it also contains some impurities of silica SiO2 plus coke, that is a form of carbon, plus limestone, that is calcium carbonate CaCO3. This whole mixture that we are introducing in this apparatus is known as charge. So the mixture of ore, impurity, coke and limestone is known as charge in this process, and we introduce this charge from upper side. And here is a temperature varying in different position or different heights in this apparatus or in blast furnace. As we go down, the temperature will be increased because hot air present here, or we can say that hot air introduced from here. So here the temperature is very high, and we go from for upper side, and we observe that the temperature will be reduced. So in lower side temperature is high, and in upper side temperature is low. So the metal which is obtained here is in molten form because here temperature is very high, and also slag that is obtained here in as upper layer of molten metal, or it will be float on molten metal, is also present in liquid form because here temperature is very high. So slag and molten metal both are in liquid form, but density of molten metal is high, so it will be in lower side, and the density of slag is low, so this will be on top of metal, or this will float on metal. So here we obtain mixture of slag, and here we obtain slag and molten metal. and unwanted impurities or unwanted gases will be removed from upper side, or we can say there is provinces of some outlets from which the gases which are produced in this process will be expelled. Now we can discuss the reactions involving in this process. As we introduce hematite, that is Fe2O3 plus silica, that is present in form of impurities, coke, that is a form of carbon, plus calcium carbonate, that is known as limestone, and this whole is known as charge. When we introduce charge in blast furnace, then smelting process taking place, and after this process ferric oxide convert into iron, that will be obtained in molten or liquid state. So this is molten metal or molten iron. Plus when carbon react with oxygen, it form carbon monoxide. So carbon monoxide is also obtained. Calcium carbonate break into calcium oxide plus CO2, and calcium oxide react with this silica and form calcium silicate, and this is also in liquid form or molten form, and this is known as slag. So after this process mainly we obtain molten iron, calcium silicate and CO2 gas. This CO gas also react with ferric oxide or hematite again and converted into CO2. So we can say that after reaction we get iron, carbon dioxide and slag. Carbon dioxide is in gaseous form, so they will be expelled from blast furnace, and iron and slag will be present inside the furnace and in lower position. And density of iron is, after smelting we obtain mainly CO2, slag and iron. Lower layer is of iron because density of iron is high, upper layer of slag because density of slag is low, and CO2 will be X because it is in gaseous form. Now we can write the equation or the chemical reaction which are involving in this process. Firstly, calcium carbonate break in presence of heat into calcium oxide plus CO2. Then calcium oxide react with silica which is present in ore particles, and it will convert into calcium silicate in presence of heat, and it will be formed in liquid form, that is known as slag. In this process silica is impurity and calcium oxide is known as flux because it is used to form slag. So we can say that flux react with impurities and form slag in this process. And here silica is acidic impurity, so we use basic flux. If the impurity is basic, then we use acidic. So in this process acidic impurity is present, so we use basic flux, that is calcium oxide, and it will be formed slag with impurity. So first product is calcium silicate, that is slag. Now second reaction, when ferric oxide, that is hematite, react with carbon, it form iron plus carbon monoxide. Carbon react with oxygen and form carbon monoxide, and here 2 iron present, so we can write 2 here, and here 3 oxygen present, so we can write 3 here, and 3 carbon present, so we can write 3 here. And this is also done in presence of heat. After this process we obtain iron and carbon monoxide. Carbon monoxide further react with Fe2O3 and form iron plus carbon dioxide. Here we can write 3 here. 3 carbon monoxide react with 3 oxygen and form 3 carbon dioxide, and here we can write 2 because 2 iron present here. So in this process carbon monoxide converted into carbon dioxide. So overall we get slag, iron, that is also in molten form or in liquid state, and CO2 that will be in gaseous state. So these are the products or overall products of this reaction of this method, that is smelting. And now we get iron from this method. Note here we obtain molten iron by this process, and after casting or molding of this molten iron, we obtain pig iron, or it is also known as cast iron, and it contains 2 to 4.5% of carbon with trace amount of sulfur, phosphorus, manganese, and other etc. impurities. So we can say that this iron is approximately 98% pure with some impurities of carbon, sulfur, phosphorus, manganese, etc. And we can also obtain wrought iron from this pig iron or cast iron. And wrought iron contains iron plus carbon. Here the percentage of carbon is very low. Here 0.25% carbon present here. So we can say that it is the purest form of iron. And we can also form steel from iron. Steel also contain iron plus carbon, but the percentage of carbon in steel is 0.5 to 1.5%. So we can say that here three type of iron present. First one is cast iron or pig iron that contains 2 to 4.5% carbon with impurities of sulfur, phosphorus and manganese. And second one is wrought iron which contains 0.25% carbon and is the purest form of iron. Then the steel that contains 0.5 to 1.5% carbon, and we can also form stainless steel. We can also form stainless steel by introducing nickel and chromium in steel, and this steel doesn't show rusting, or it is a anti-rust.